Welcome to Pomodoro Joe for Saturday, April 22nd, 2023. Today we're doing LeetCode problem 1312, minimum insertion steps to make a string palindrome. All right, this is a hard problem. So given a string S, in one step, you can insert any character at any index of the string. Return the minimum number of steps to make S a palindrome. A palindrome string is one that reads the same backwards as well as forwards. All right, and then they have some examples, but I think this one's pretty straightforward. Yeah, I think this is going to be an easier hard problem. So with that, we'll put 25 minutes on the Pomodoro timer, and we will get started. So for this one, we can only insert characters. We can never remove characters. And that's kind of key, because we can't remove characters, we can only add new characters, which means that we can actually just go and find where do we need to insert a character. And that sounds more complicated than it really is. So let's take a look here. So we'll have a result, and we'll set that equal to 0 to start, and we will return the result at the end. All right. Now you know me, so we're going to do this recursively. So we're going to have a min insertions recurse. Now what will this take? So my plan here is to say, let's have pointers to either side of our string. So we'll have, let's just do an example here. Let's see, what's a good one? We'll just do, okay, so let's assume this is our string. So we'll take a look at the first character, and then we'll also take a look at the last character. Now, we'll compare these two characters. If they match, that means we have a potential palindrome, because they are in the same place on either side of the string, and they're matching characters. So that could be a palindrome. If they don't match, however, so let's actually start with this. Let's say it's something like this. Okay, so we have AA, B, AA, and we look at the left and the right, and they match. So what we can do is just say, well, we know that those two match, so we'll move our pointers in. And we'll check the next two, and those also match. So then we can move our pointers in, and at this point, the pointers are in the same place, and we have a palindrome. Now, what happens if they don't match? So let's say we have something like this. So AABAB. Now if we look at these two pointers, they don't match. So that means we need to insert a character somewhere. We either need to insert a character on the left or we need to insert a character on the right. We don't really know which one we're going to insert, but we have two options. Let's just see what our two options are here. All right, so option one, we can insert a character on the right. So let's see, we'd insert an A because we want it to match. So we'd insert an A here. Now this outer A matches this outer A, but we're not moving our pointer, so we still point to B. And we'd move this pointer in because we know that the outer A's match, so we can move this pointer in, which means we have another one that doesn't match. So we'd either have to do this again, we'd recurse. The other option is down here. Let's add a character onto the left side. So if we add a B onto the left side, we're not going to move our A pointer. We'll keep our, we're not going to move our left pointer. We'll keep our right pointer where it is. So now we've got these two B's matching, but we can move our right pointer in, and that matches. So now our A and our B match, or our A and our A match. And then at this point, we'd have to do another recursive call because we would move this guy in and we'd move this guy in and they don't match. So we'd have to do another recursive call. All right, I don't know if that makes a ton of sense, but hopefully once we get coding, it'll make sense. All right, so we need to keep track of our left and our right characters. So we'll have a left and we'll have a right. Okay, and then we'll have some internal result here. Okay, what's our base case? Let's actually start with that. So the base case is the left and the right are at the same place, or the left has passed the right. So if left is greater than or equal to right, that means we're at the same place or the left has gone past the right. And at this point, we know that there's either one character or no characters. So we can return 0. We don't need to do anything. Okay, then we have two other options. Actually, we might not even need this result here. So if the left is past the right, we're done. We return 0. All right, now we get to our first recursive case. So we'll check the characters at the left and the right. So if the string left is equal to the string right. So this is the case where the outer characters match. That means we can move both pointers closer together. So we'll just say, we'll do our recursive call. That'll be left plus 1 and right minus 1. So we're moving them closer together. The outer characters match, so we just move these two closer together. Okay, now if we make it past that, we know that they don't match. So we have two options. So we have option 1. That's where we'll add a character to the left, and then we'll advance our right pointer. So let's do that. So we have to do an insertion at this point. So this will be 1 plus, because we did one insertion operation. We're going to keep the left at the same place because we're adding a character to the left. So it kind of goes on the outside of our pointer. And then we'll move our right closer because we're matching our right's character. All right, and then option 2 is virtually the same, except we're going to add a character on the right and we'll move the left closer. So we'll say left plus 1 and right. So again, with this first one, we're saying we're going to add a character on the left side, which we're going to be outside of our left pointer. So to the left of our left pointer. It's going to match the character on the right-hand side. So now we have two matching characters, but our left pointer is already advanced because we've put this outside of our left. So we just need to advance the right pointer to get a little bit closer to the left and see if we can get a match there. Same thing with this left and right. And then at the end, we have to return whichever one is smaller. So whichever option gives us the best answer, we'll return that. All right, so that's basically it. Here we need to do the initial call. So our result will equal this min recurse. Whoops, grab this whole thing. And let's see, for the left, we'll pass in index 0, and for the right, we'll pass in the length of our string -1. And at the end, we'll return our result. So we actually don't necessarily need this. So let's get rid of that. And in fact, we don't need this result at all, so we can just return. Make it a little bit cleaner here. Okay, let's see if this will work. And that works. Let's see if we can pass all the runtime checks. All right, time limit is exceeded. We only passed 12 out of the 56. So let's use that test case here. And what can we do to speed this up? Well, the simplest thing we can do is caching. So we'll just add our functools cache. Now this function decorator will let us essentially cache out the result from any call to this function that has the same input parameters. And then we don't have to do the entire calculation again. We just return the cached result. All right, let's see if this makes a difference. All right, we're passing this one test case we didn't pass before. So let's see if we can pass all the tests. And we pass. And we do okay. So we beat 61% for runtime and 14% for memory. So that's not too bad. Now we could do one simple thing here. These min calculations, this is a function call. If we can avoid function calls, we can speed this up. So let's do our own min calculation here. So we'll return option 1 if option 1 is less than option 2. Else we'll return option 2. All right, let's see how that works. Still works. Let's see if it gives us any type of increase. We were in the 60% before. Let's see what we get now. A little increase. So we're at 69%. We were at 61. Now we're at 69%. It's a little bit of a boost. Now, there's probably some other things we could do in here, but I like how simple and clean this is. It's pretty straightforward. It's easy to understand. We could probably add something where it's like when we get into the function, we can immediately check, is this string a palindrome? It may or may not save us anything. If you want, we can do that. Let's actually do that here. So if left is greater than or equal to right, we'll return 0. And also if string is equal to the reverse of itself. And that we can do by calling s : it's slicing it with a -1 step, essentially. So that's just checking if it is a palindrome, if we already have a palindrome, but we actually need to do this a little bit differently. It's s from left to right plus 1 because it's not inclusive. I think that works. I'm not 100% sure on that. We might want to do the slice and then store it. That might be better, actually. Let's see if this works. So this is just earlying out if we get to a point where we have a palindrome. That doesn't actually save us anything. I might do one little tweak to it here. So we're just going to do that slice one time, and then we'll do the reverse here. Okay. So this may or may not help us. We're only doing the slice once instead of twice. It makes it worse, 48%. Okay, so this early out doesn't actually help us. So we'll just get rid of that, and we'll go back to our original solution here, which I like. So we'll go through, we'll have a recursive call. So we start the recursive call by passing a left and a right, which is at either end of our string, index 0 or index at length of s minus 1. Next, we'll just check if our left and right index are past each other or at the same place. We have no swaps to do, we're done. Otherwise, we can check to see if the character at the left matches the character at the right. If they do match, then we can just move each of these pointers closer to each other. We'll just ignore those characters. Otherwise, we have two options. We either add a character to the left-hand side and advance our right pointer, or we add a character to our right-hand side and we advance our left pointer. And finally, we'll return whichever option gives us the better answer. All right, so that's it for me. Let's see, we did okay. We didn't get the best solution here, but we got 69% for runtime and 14% for memory, so it's not too bad. Try this one out, see if you can get a better score. I bet you can. There's lots of things you can do to this one. So that's it for me. Hope you enjoyed this, hope you had fun, hope you learned something. Hope you can go out and write better code.